Today we have the following task: to sketch y equals x all over root 1 minus x squared. So the first thing I'd consider is our domain. We know that a denominator cannot be less than 0, neither can it be equal to 0. So if we have root 1 minus x squared is greater than 0, 1 minus x squared is greater than 0. And if you flip our sign, so we've got positive x squared minus 1 is less than 0. Factorize x squared minus 1. We've got this inequality. And we need to find the region the graph is below the x-axis, and that would be here. The roots minus 1, 1. So our domain is minus 1 is less than x, which is less than 1. Now the next thing to consider here is our range. So we know as we take the limit, x goes to 1. Well, if we have 1 over a really small number, which is close to 0, then we just tend towards infinity. Now let's look at x and y intercepts. When x equals 0, y also equals 0, and when y equals 0, x also equals 0. So we know that we're going through the origin. Now let's see if we have any stationary points. So y equals x over root 1 minus x squared differentiates to, well, we can actually write this out a bit more simply. So instead of using quotient rule, we can use product rule. So this differentiation 1 minus x squared to the minus half plus x squared 1 minus x squared to the minus 3 over 2. Well, we can write this as 1 all over root 1 minus x squared plus x squared over root 1 minus x squared cubed. And to find the stationary points, we set our gradient function to 0. So 1 over root 1 minus x squared plus x squared root 1 minus x squared 3 equals 0. We times through by a denominator here, so we get 1 root 1 minus x squared all squared plus x squared equals 0. This simplifies to 1 minus x squared plus x squared equals 0. We've got 1 on the left hand side and 0 on the right, which means there are no stationary points. The last thing to consider now is whether this is an even or odd function. Well, an even function is defined as when f of minus x equals f of x, and an odd function is defined as when f of minus x equals minus fx. So let's see. fx equals x root 1 minus x squared. F of minus x equals minus x all over root 1 minus x all squared, which simplifies to f minus x equals minus x all over root 1 minus x squared. And we know that we've got f of x here, So this whole part is minus fx. Therefore, fx is an odd function. Now let's sketch our graph. So we know we are bounded by -1 and 1. And since we've got an odd function, anything in this quadrant here will be rotated 180 degrees. So let's draw our vertical asymptotes. And we know that as x goes towards 1, y becomes really large. And since we just rotate this part of the graph into the -y, we get this sketch. Now an alternative way to sketch our graph is by looking at our fraction as two separate functions. So y equals f of x over g of x, where f of x is x and g of x is √1 minus x squared. So let's sketch f of x with our domain 1, x, 1. One minus 1, and g of x, well, for now this isn't an easy sketch, but we can work our way around it. We've got y equals √1 minus x squared, y squared equals 1 minus x squared, x squared plus y squared equals 1. And well, this is just similar to a unit circle. However, we cannot draw the negative part since our sketch will not be a function. So minus 1, 1, and 1. And now, if we divide our first graph by a second, again, we got a shape like this. And now you have two ways to sketch this graph. Thank you.